Welcome to section 4.2. Today we're diving into how experiments are designed, why randomization and control matter, and how you can use software like Excel and R to support solid experimental planning. A well-designed experiment lets us make causal claims with confidence. If you need a reminder on what causal claims are, go back and review section 4.1. Designing an experiment isn't just about applying a treatment and recording results. It's about eliminating alternative explanations. If we don't control for outside influences or introduce random variation properly, our results can mislead us. Have you ever tried something and thought, it worked, but then wondered if something else caused it? That's why we care about experimental design. There are 4 key principles that drive trustworthy experiments. Randomization prevents bias by distributing unknown variables across groups. Control helps isolate the treatment's effect by holding other variables constant. Replication increases reliability. It shows results aren't a fluke. Blinding reduces bias from participants or researchers knowing who got what. A well-designed experiment incorporates all of these. Every experiment needs clarity on experimental units, what's being measured, people, animals, plants, etc. Treatment, the intervention being tested. Factor, the independent variable being manipulated. For example, if we're studying how fertilizer affects tomato growth, the plant is the experimental unit, the fertilizer is the treatment, and the factor might be nitrogen level. There are a few common experimental designs. Completely randomized design. CRD participants are randomly assigned to groups. Randomized block design, RBD subjects are grouped into blocks, then randomly assigned. Great when you expect group differences. Matched pairs design. Pairs of similar units receive different treatments. Often used in medical trials. You'll often choose a design based on practical constraints or ethical requirements. Prompt question. If you had a group of athletes from different sports, would you randomize them directly or block by sport first? Take a moment to stop the video and record your response. Let's say we have 20 patients and want to randomly assign 10 to treatment, 10 to control. Enter names in a column. Next to them, use equals rand. In Excel, sort the random numbers. Assign the top 10 to treatment, bottom 10 to control. This simulates randomization, a key to reducing bias. Now in R, we can do something similar. Watch what the R code below can do. This simulates outcome data where treatment has a stronger mean. You can visualize it instantly. Try adjusting means or standard deviation to see what happens. One of the most famous randomized experiments was the Salk polio vaccine trial. It involved over 1 million children, with some receiving the vaccine and others a placebo. It was randomized, double-blinded, and massive in scale. It's credited with proving the vaccine's effectiveness. Without such design rigor, it could have failed despite working, or looked effective even if it didn't. Even with planning, things can go wrong. Forgetting to replicate, small sample sizes, assigning treatment non-randomly, letting participants drop out or switch groups, not blinding, which can cause subtle behavior shifts. A reminder: a bad design wastes data, effort, and sometimes lives, especially in medicine or policy. I'll pass out some brief study summaries. In your pairs or groups, identify the experimental unit, the treatment, the control, if any, the type of design used. Let's take 8 to 10 minutes. Then we'll walk through one or two together. To summarize, experimental design allows us to make stronger causal conclusions. Randomization, control, replication, and blinding are critical. Tools like Excel and R can support design and analysis. Choose your design carefully, based on goals, ethics, and feasibility. Before you go, answer this prompt on paper or submit in Canvas. Which element of experimental design do you think is most often neglected in real life and why? Also, a quick reminder. Your Week 4 quiz is due Saturday by 11:59 p.m. No late submissions.